Okay, this is a video example for finding the volume of solids formed when their cross sections are certain shapes. So they could all be equilateral triangles or semicircles or some variation of that. So we've got a pair of functions forming a region which is labeled with capital R, and we've got a trig function sine of pi times x. So that's going to be my upper function, if you will, in terms of the area of that region R. And then I've got my cubic function, and obviously just one part of it. But here's my cubic function, x cubed minus 4x. So if I go ahead and take a look at one of these, and I think if we do one example, you're going to get the idea of this, of how you can apply the formulas that we derived in class. So I actually am going to start with those. I'm not going to rederive everything. I want to find the volume of the solid formed when all the cross sections are equilateral triangles. So I'm picturing that I'm forming equilateral triangles by taking one cross section, so that's one slice, and making an equilateral triangle off of that, but I'm doing that a bunch of times. So I'm doing that here. Obviously that's a bigger equilateral triangle. Okay, that didn't look equilateral. And I'd be doing that all the way across from here, starting at my origin all the way over to here, and taking a whole bunch of slices with respect to my x-axis, because it says perpendicular to the x-axis. So that's pretty important, and I'll give you a hint. The next question doesn't have perpendicular to the x-axis. It is perpendicular to the y-axis. If I was perpendicular to the y-axis, I'd be taking a slice across left to right. Okay, because I'm going perpendicular to the x-axis, the base of my triangle and my whole derivation came from f of x minus g of x, f of x being my top function, minus my lower function, gives me this distance between here. That's really the area between the curve. If I add up a whole bunch of slices, rectangles here, I'm using that as the base of my equilateral triangle. So in my formula, we had developed that we had radical 3 over 4 times the integral from a to b, in this case that's 0 to 2, of f of x minus g of x, and we're going to go ahead and put in there that that's sine of pi x minus my function, be careful, use your parentheses here, x cubed minus 4x, and all of that, my f of x minus g of x, is squared. So there's my f of x, and there's my g of x that I'm subtracting. And for this one, I would go ahead and use your calculator. I really want you to just focus on the setup here. And if you type that in the calculator, I'm getting, for my answer for the integral, you can do it all at once, but just as a checkpoint, 9.9783444. And that's being multiplied by radical 3 over 4. So my final answer there is actually 4.321. Hey, that's a pretty cool number, guys. 4.321 units cubed. Now, feel free to use some of what you just did as you go through the other ones. Because we noticed some patterns in class, and I would encourage you to use those patterns if you're asked to do multiple different variations of find the volume of the solid. Just to look at something that's a little different, E and F are different than what we did in class, and you don't have a formula for that, but I think we can think through it. So we've got, this time, cross sections are rectangles whose height is twice the length of the base. So if I'm trying to picture that, I'm going to go back to what we did in class, which is we derived formulas. So our formulas came from, let's look at the geometry. So I'm going to come back to this box in just a second, but I'm going to do a little scribbling down here. And I'm going to figure out what exactly I'm going to use here. So my volume of a rectangle, my area of a rectangle whose height is twice the length of the base. So here's the rectangle I'm looking at. And remember, my base is coming from my slice, which is f of x minus g of x. So if I'm taking the rectangle is 2 times as high as it is wide, then that's going to be 2 times what my base is, which is f of x minus g of x. So when we talk about the area of that rectangle, area of a rectangle is base times height. Well, it's looking like the area is going to be f of x minus g of x. I need to give myself a little bit more room, times 2 times, and if you followed at all what we were doing in class, then you should be seeing that there's that repeated f of x minus g of x. So we could certainly simplify that and get that that's going to be f of x minus g of x quantity squared times 2. 2 is my factor out front. So that's the area of one rectangle. If I can establish that that's the area of one rectangle, my calculus tool of integration will allow me to add up a whole bunch of areas and ultimately get the volume when I add up the area of all those slices. So that's my new formula for what I'm going to do. So let's carry that up here. Here's my original question, part E. And two times the integral of, drop this in, f of x minus g of x. And we already found that up above. We found that in part A. Our answer was 9.978344 when we integrated our given functions from 0 to 2 is what we had done. So I'm going to have 2 times that for a final answer of 19.957 cubic units for the volume of this solid. Should make sense that that one's considerably higher than our other one because we're doing rectangles instead of triangles, and we're also making them twice as high as what our triangles were. Well, as what square would be, and that's even higher than what the triangles were. I'm going to let you work through the rest of them because I think that you can do the rest from here. I'm going to warn you again that number 3 has cross sections that are perpendicular to the y-axis. So you should be slicing horizontally, and that should tell you something about how you're going to set up your integral. I think that you'll be able to work through the rest of them. So good luck. If it's a pretty easy one, you can go ahead and try to do it by hand, but I do want you to be able to do it in the calculator, so go ahead and use your calculator for this one and try something like number 3 by hand or number 5 by hand.